Okay, so estimating a population mean with sigma known, our assumptions are that the sample is a simple random sample. That was the same for the proportion. The value of the population standard deviation sigma is known. That's our assumption over here. Either or both of these conditions are satisfied. The population is normally distributed, or the sample size is greater than 30. So that is going to be our requirement. In order to find the confidence interval, we either have to have a normal population to begin with, in which case we don't care about the sample size at all, or if that's not the case, then we want to have a sample size greater than 30. And many times we will have both of these requirements met, but only one of them is necessary. So a confidence interval is a range or an interval of values used to estimate the true value of the population parameter. The confidence level gives us the success rate of the procedure used to construct the confidence interval. So we're now going to look at the mean. The margin of error is the maximum likely difference observed between sample mean and population mean, and is denoted by E. So we are starting with our sample mean. We're going to calculate the margin of error. We're going to subtract and add that number, and that's going to give us the confidence interval, or our estimate. We're going to believe, with a certain percentage that our population parameter is included in that. Sometimes it falls outside, and 5% of the times we make the wrong conclusion. So example 1, a study found the body temperature of 106 healthy adults. The sample mean was 98.2. And the population standard deviation is known to be 0.62 degrees. Find the margin of error E and the 95% confidence interval for mu. The important thing over here is that the population standard deviation sigma is known. Sometimes it states it just like that, or sometimes it just says, oh, sigma is equal to some number. So in either case, you'll know that we know the population standard deviation. If it doesn't clearly state so, then assume that it's probably the sample standard deviation that's given. So let's say we say there's a sample of 100 people, their mean is 98.2, and their standard deviation is 2.3. Then we're going to assume that's our sample data, and we don't know the population standard deviation. So it has to very clearly state when we have the population standard deviation given. Okay, so what is the 106? That's our n. N is 106. The sample mean. What was the letter we used for the sample mean? X with a line, X bar. And then the population standard deviation we used, our sigma. Okay, we're trying to find the margin of error, and just like before, we'll do one manual example, and then for all the other examples, I just want you guys to use a calculator. Okay, so our margin of error is equal to our critical value, Z alpha half, times sigma divided by the square root of n. We do have a 95% confidence interval, so you see this one keeps coming back. What's the critical value? Okay, our sigma. And then the square root of our sample size, which is 106. Okay, so let's plug this in. 1.96 times 0.62 divided by the square root of 106 is a margin of error of 0.118. Okay, so now we're going to take our X bar, our sample mean, we're going to subtract the margin of error, and we're also going to add the margin of error. So X bar was 98.2 minus 0.118, and then 98.2 plus 0.118. And then our rounding rule is going to be a little different. So for the proportion, we always have numbers between 0 and 1. This is why we're going to round it to 3 significant digits. But over here we have kind of, many times we have much larger numbers, so we don't need to have that many decimal numbers. So in fact, we can't get any more accurate than our starting point, which was that sample mean. So if the sample mean is rounded to 1 decimal, we're also going to round our limits to 1 decimal. So 98.2 minus 0.0118 is rounded to 1 decimal. That's 98.1. And then we're going to do 98.2 plus 0.118. And again, rounded to 1 decimal, that's 98.3. Or we could give it as an interval 98.1 to 98.3. So this is our answer over here. Now to look at our shortcut, it said on the formula sheet that we're using the z interval. So let's just compare how fast it is. Go to stat, error to test, and then go to z interval, which is number 7. Over here we have 2 choices. Do we have data or do we have summary stats? In our example we have stats, right? But if we had data, we could put those into a list and we could do the same test with the data. Then it says, what is sigma? So here's another point, where you can go back and say, hey, do I actually have a sigma or do I have an S given? Just another way to check your answer. What is our X bar? Well, that was given as 98.2. That's our sample mean. What is our sample size? That was 106. Our confidence level is 0.95. And then you're going to hit once in order to get the interval, and the lower limit, rounded to 1 decimal, bless you, is 98.2, and the upper limit is 98.3. So super easy to actually find it on that sheet. Okay, so